Namaste students. So today we can discuss about Newton's law of motion. So Newton actually he described what is force, how the force will act, so what changes the force will make. So actually you studied. So velocity will change from initial velocity to final velocity. The reason is acceleration. Correct? So what is how when you will get the acceleration? So what is the reason for that one? So that is explained by Newton's law of motion. So he told for acceleration the reason is force. Now here so actually Isaac Newton he took that concept from Galileo's observation and his three laws are there. So from that he made some changes and he gave three equations or laws of motion. So mainly he took the ideas from whose it is Galileo's observations. Now from Galileo his experiments. So what he concluded by doing so many practical experiments, he concluded that an object at rest continues to be rest until and unless the force exerted on another object. For example, if force is not acting on that object, it will remain in the state of rest only. An object set in motion retards and eventually stops if there is a force in opposite motion or opposite direction. For example, object is there, if you apply force in the opposite direction, then that object will stop after traveling some distance. So that is about second conclusion of Galileo's. The third one is an object set in motion moves with a constant velocity if there is no net force acting on that. For example, object is moving with the constant velocity, it will move in a constant velocity if there is no force acting on that. So before this conclusion, Galileo, Aristotle, he observed that and he gave that if an object is moving with the constant velocity, if you have to move an object with the constant velocity, the force is required. So that is before that one. After that, it is told it is a false statement. So this will be the correct statement. Now, so Newton took these ideas and he formulated Newton's laws of motion. So these observations are summed up in Newton's first law of motion. It states that, so according to Newton's law of motion, what is that? Every body continues to be in the state of rest or uniform motion in a straight line unless coupled by an unbalanced external force. Means if the external force is not there, it will continue in the state of rest or uniform motion. So that is the first Newton's laws of motion. So in simple way you can say that if this one, the total force, summation of force, I am not saying only one force is acting on that body, it may be so many, a number of n forces are acting on that body. So if you add all the forces, then you are getting the answer as 0, then acceleration of that body is 0. Acceleration of the body is 0 means when that body, it will move in a constant velocity or it will remain in the state of rest. So how, if n forces are acting, how we are getting answer as 0? Because if one force is acting in this direction, there will be for that force in opposite direction also another force will be there. If 5 Newton is acting in this direction, 5 Newton will be there in the opposite direction. So 5, this will be minus 1. Total you will get as 0. So like that, if 20 forces are there means that 10 and another 10, then cancel each other. So total force you will get as 0, then acceleration of the body is equal to 0 you will get. That is, if a body at rest tends to remain at the rest and a body which is moving continues to move. The intrinsic property of material of body which resists the change in state of rest or uniform motion along a straight line is called inertia. So what is the inertia? The property of the body which is oppose the change in state. Means body which is in the state of rest, it will remain in the state of rest. The body which is moving with the constant velocity, it will remain with the constant velocity. It opposes, every body opposes the change in state. So that the property is called what? Inertia. So inertia is the natural tendency of a body. Now For example, mass is there. For example, two bodies are moving with the constant velocity. Then, if you want to stop the two bodies, for which one you have to apply more force? So, by observation you can make out that if mass is more, you have to apply more force. So mass is more means it will oppose more, it will have more inertia. Correct? If mass is more means opposition. Opposition means what? Inertia. So for example, if the larger the mass of the body, greater the difficulty to bring about the change in its state of motion. That is, mass is a measure of inertia. Mass is a measure of inertia. So inertia is a property. So in physics you want to measure that inertia. So how we are measuring inertia? Just by taking mass. Mass is a measure of inertia. So why we can measure the inertia as a mass? So mass is the measure of inertia because if mass is more, inertia is more. If mass is less, inertia is less. So directly inertia is measured as, that is, mass. So there are two types of inertia: inertia of rest and inertia of motion. The tendency of body at rest, because its state of rest, is called inertia of rest. For example, when body is in the state of rest, it will remain in the state of rest only. That property is called inertia of rest. Now here we can study some example here. A passenger standing or sitting in a bus or a train falls back when it starts suddenly. This is because the lower part of the body moves forward with the bus, while the upper part of the body continues to be in the state of rest. For example, if you are standing in a bus, when bus suddenly it started, your upper part is, so your falls back. Why it is? Because your lower part is, it is started to moving, correct? But your upper part is, what happens here? If this is lower part, this is moving. So this will be a state of rest only. So your falls back, correct? So this is part in the state of inertia. With the bus, this part will move. So this part will be in the state of rest. So these are the examples for inertia in rest. So you can take the second example. If we place a coin over a card on a tumbler, if you lift the card quickly away with the finger, the coin falls into the tumbler as a card moves away quickly. So here we have, for example, one glass is there. Above that you have to place one card. Above that you have to place one coin. So if you remove this card quickly, the coin will fall there only. Correct? With that card, the coin is not moving. So why? Because of inertia. Inertia, the coin will remain there only and it will fall to that tumbler. So that is the example for inertia of a rest. Inertia of motion. So easily you can work out here. The tendency of a moving body to preserve its motion in a straight line with the uniform velocity is known as inertia of motion. So for one body is moving with velocity v, it will remain in the velocity v only unless you apply any forces in a straight line. So that is called inertia of motion. Now, so example you can give. For example, a person is moving a vehicle, falls forward when suddenly stops. So here a person is moving, suddenly stops. So first this lower part will come to rest. So this entire body is moving forward only. So this comes to rest. So he falls like this. Correct? So it's the inertia of motion example. Before taking long jump, an athlete runs some distance so that the inertia of motion might help him to jump longer distance. For example, the long jump, he is jumping from here only. So suddenly from rest to motion he is going. Correct? So it is difficult. So running and he is coming means again he is in running only. So easily he can jump. Correct? So that is the example you can give for inertia of a motion. Now, so what is force? So force is regarded as a cause of motion. We can visualize a force as a push or a pull or a stretch or a squeeze, and you can do one or more of the following when applied on an object. So regarded as a cause of motion. So what is the reason for motion? For example, the state of rest is that if you want to move that object, you want force. Now it may produce or tend to produce a motion, stop or tend to stop a motion, speed up or slow down a moving object, change the direction of a motion. So without doing these three, it may change the direction of motion. It is moving with the constant, for example, object is moving with constant velocity. Now it is moving in this direction, it is moving with the constant velocity. So without the help of force, you can't change the direction. If you want to change the direction also, then also you need what? Force. So force is a physical cause which changes or tends to change the state of rest or uniform motion or direction of uniform motion of an object. For example, it will change the motion from rest to motion or motion to rest, or it will change the direction. For example, you tie on stone to thread, you rotate. So it will rotate when the force is applied. Then only it will rotate with the constant velocity. That means if it is moving in a circular path like this, at every point its direction is changes. It may rotate with the same velocity. Magnitude of velocity will be same, but its direction is different in a circular path. So in that case also you need what? Force is necessary to change the direction. Now you can see some fundamental force in nature. Actually, we are studying 4 fundamental forces in nature. The first one is gravitational force, so that you know. So when the two masses are there, two mass. So between the two masses there will be a force will be there. Always attractive force, that is called gravitational force. The force between two masses. Electromagnetic force. So these are force between two charges. What is that? Two charges. If two charges are plus or minus, so between that there will be a force because of that charge, that is called electromagnetic force. Strong nuclear forces. So strong nuclear forces. So this force inside the nucleus, nucleons. So there will be a force between nucleons. That means proton and neutron, or proton and proton. So what is the force? So that is strong nuclear force. So this force binds the nucleus. So nucleons are inside the nucleus because of which force? The strong nuclear force. Example. Weak nuclear forces. So this also nuclear force. Where it will arise? Inside nucleus. So it is called nuclear forces. Strong and weak nuclear forces. So it arises due to the weak interaction. So we will study about this one. What is weak nuclear forces? Here just to remember, this is a force inside a nucleus. Momentum. Now here, so this is one concept. For example, two objects are moving with different mass but constant velocity. Now, if you want to give, if you want to stop that two objects, the mass you have to apply different force. Correct? For which you have large mass, you have to apply more force. Correct? For example, two masses of different two masses, the masses are different. You want to, which are in the rest, you want to give same velocity. So for which one you have to apply more force? So which is mass is more, for that you have to apply more force. Correct? Now, for example, two masses, mass is same. You want to give more different velocities. Which are in the rest, you want to give the different velocities. For which one you want to give more velocity, you want to give what? More force. So this mass is depends on, or force is depends on mass and velocity. Correct? If you want to give more velocity, you have to apply more force. If you want to give more for same velocity for different mass, if mass is more, you have to apply more force. So by practical observations, we define one term, so which will help understand the force, that we are saying as momentum. What is that? Momentum. So momentum is a quantity of motion associated with the body, and it is measured by the product of mass and velocity of the body. So P is equal to m into V. So it is a vector quantity, and you can make out the SI unit of that momentum. So what is this one? So also you can see this Pm into V. When the force is not acting, what is there any change in mass? So is there any change in velocity? So both the terms will remain constant. Both the terms will remain constant means P also constant. So you can say that when force is equal to 0, this P will remain as constant. So momentum is a constant. So Newton's second law. So based on momentum definition, so Newton's second law is that. So the second law of motion deals with the measurement of force. It gives the quantity of relation between the force and the force applied to the body and resistance produced. Now what is that? The rate of change of momentum of a body is directly proportional to the imposed force in the direction of the force. The rate of change of momentum is directly proportional. Rate of change of momentum. So how momentum will change with respect to time? That is called rate of change of momentum. Momentum divided by time. Now here you can see. Consider a body of mass m is moving with an initial velocity u. It is accelerated velocity v in a time t. By an application of a constant force f, that a be the acceleration of the body, then you can find. So body is moving with the initial velocity u of mass m. Then what is the initial momentum? M into u. Now its velocity is v. Then what is final velocity? M into v. So that you can write. So its momentum is changes by mv minus mu. Final momentum minus initial momentum. That is the change in momentum. What is the time here? T. Now according to Newton's second law, F is directly proportional to rate of change of momentum. Directly proportional to rate of change of momentum. Then you can write F momentum what? Change in momentum. mv minus mu. Rate means it is divided by T. So m you can take it as common. We will get v minus u divided by T. But v minus u divided by T is what? Acceleration. That you know the definition of acceleration. So F is directly proportional to m into a. You can write. Now here, so if you want to remove this one, you also make it as F is equal to k into ma. Now here for SI units, you can take k is equal to 1. So why you can take k is equal to 1 means because you are defining the force first time. If you are defining first time means if you take k is equal to 1 or k is equal to 2 or k is equal to 3, it will not make any difference in the measurement. So here for easiness, we are taking k is equal to 1 and you are writing F is equal to m into a. So that is the equation you got from Newton's second law. So weight. So what is weight? So weight also force. We know that any body on the surface of the earth is pulled towards the center of earth if the body is at rest. The body in the state of rest, it is pulled towards the center of earth. So this force of the body pulled towards the center of earth is called weight. So weight means it is the force. Now the weight of the body is the gravitational force exerted on the earth. So weight means it is the gravitational force exerted on the earth. So what is the difference between mass and weight? So mass of the body is the amount of substance in the body which measures the inertia of the body. You can say it is amount of substance. What is weight? It is the force of attraction toward the center. So mass is a scalar quantity that you know. Weight means a force. Force is a vector quantity. Mass of the body is same in all the places. That is correct. Weight of the body depends on g. G means acceleration due to gravity. So if this is g is different. So weight on the surface of earth at different place of the earth, g is different. For example, you go for equator, from equator g is different. North pole g is different. So weight is varying here. Correct. Mass of the body is measured on the common balance. Common balance means that you know in this they will put weight and they will measure. Weight of the body is measured by a spring balance. Spring balance, they will take one spring and they will hang. Correct. So that is spring balance. So using that weight is measured. Now here one example is given how to convert mass to weight. So 2 kg is there means m into a, that is the force. So here a is g, that is the value is 9.8. So you can take it as 19.6. You will get as weight. Now Newton's third law of motion. So Newton's third law of motion says that whenever a force is applied, there are two bodies involved in the process. The body which applying the force and the body on which the force is applied. So two forces. That means for a single body, the same body, you can't apply forces. There will be two bodies. So one body will apply force, the another body will give the reaction. So one you can say action and another body will give the reaction. That is Newton's third law of motion. So can we take the example in a football is kick, there are two bodies involved. One is the football and one the player. The hammer drilling the nail. That also you can take the example. So what is the statement of Newton's third law? For every action there is always an equal and opposite reaction. So in the statement action and the reaction here refers to the forces. So here when an object exerts a force on a second object, the second object exerts an equal but opposite force on the first one. The two forces are always equal and opposite. Means here if say action and reaction. So here one body will apply forces, the second body apply the same force in the opposite direction. That means any force you can take it as action and reaction. If one force is action, another will be the reaction. So thus in nature forces always occur in pairs. One of the action, other one is the reaction. The force of action and reaction are simultaneous. Means at the same time you will get force and action and reaction. The time will be same. Even though the action and reaction are equal opposite, they never cancel each other because they never act on the same body. Means I told if action 5 Newton is action, minus 5 will be the reaction. So the total force you can't say it is a 0 because they will act for the different body. Now you can take the example here for Newton's third law of motion. A swimmer while swimming pushes water backwards. In reaction to this, water pushes the swimmer forward. So he is moving forward, but he is applying force in the backward direction. So here in the rocket, what happens here? The upward thrust on the rocket is caused by the rapid escaping gases through the nozzles. So here gases are moving downwards here. So that is if you consider action, the rocket is moving upward. That will be the reaction. So both forces are opposite direction and it will be the same. When we walk, the foot pushes the backward on the earth and the earth in turn exerts equal but opposite forces forward on the walker. So here you can see here he is applying force in the backward direction so that earth pushes back in the forward direction. So this is an example for action and reaction. Now conservation of momentum. So conservation of momentum already I told. P is equal to m into v. So P is equal to m into v means what you are getting? When force is equal to 0, the P will remain constant. So that is only conservation of momentum. If no net external force acts on a system, then the momentum on the body of a system is a constant. So if no forces, external force is equal to 0, momentum remains constant. That is the conservation of momentum. So rocket moves upwards using the principle of conservation of momentum. I told rocket is moving according to Newton's third law. For every action and there will equal and opposite reaction. So here, for example, is here gases are moving downwards. For this gases there will be a what is a momentum. It getting some momentum. So initially, if this rocket in the state of rest, what happens here? Total momentum what you are getting? 0. Correct? Now also, if for this gas particle, if the momentum is there, So this momentum should be cancelled by some other momentum in opposite direction. So these gas particles are moving downwards, getting some momentum. Similarly, with the same momentum, this rocket is moving up. So upward momentum is there, downward momentum is there. What is the total momentum? It is 0. So that is conservation of momentum. So thank you.